Okay, so today we're looking at factoring trinomials of this form. So you'll take a notice here that the trinomial has an x squared term, an x term, and a constant term. There's a billion different types of trinomials. We can only do it for this type. There's some variations on this type, but for today, that's what we're looking at. In Math 10C, you're going to learn a whole bunch more types of factoring. In any case, it all extends back to multiplying binomials together. So in this chart here, we have two binomials multiplied together in each row. I want you to get the simplified form. First one's done for you, remembering FOIL, if that helps you. So the next one, the first together, is x squared. The outsides together is negative 3x. I'm just going to show it here. The insides together is negative 5x. So when I collect those like terms, I get negative 8x, so subtract 8x. And the last terms together is positive 15. So because these, basically today we want to go from this form here back to the factored form. Factored means they're multiplied together. Okay. Next one, first together is x squared. The outside together is negative 5x. Inside is 12x. And last terms together, negative, so let's collect those like terms. Negative 5x plus 12x is 7x. And then negative 60. All right.
Right, your outside and inside. If these are all in x's and numbers, the outside and inside add together. They're like terms. Okay. So now we want to look at how we can go from this form back to this. Okay. Well, notice the constant terms in all of this. 4. Well, if you look at the last terms in each, 4 times 1 is 4. Negative 5 times negative 3 is 15. 12 times negative 5 is negative 60. So you want to, if you're given a trinomial like this, look for two numbers that multiply, okay, to that value. But there's more than one choice. For example, negative 60, I could have 20 and 3. So why wouldn't I choose that to go in the brackets? Because the two numbers that you choose have to add to 7. Okay? So when I choose these two numbers that multiply to negative 60, they have to add to 7. 12 plus negative 5 is 7. Because those are your outside term and your inside term. Okay? So the negative 5x plus 12x. Here, why couldn't I have 15 and 1? Well, 15 and 1 don't add to negative 8. So if I decided, oh, okay, this factors to x plus 15 times x plus 1, if I expand this out, that works. This works, but my outside and my inside add to 16x. So that doesn't work. So you have to think about factors of the constant term that add to the coefficient of x. Okay? So let's see, in this one here, this is the general case. So as you can see, if a trinomial is in this form, if it's factorable, sometimes you can't. Okay, you can't factor it. But if you can, the factors will be of this form, x plus something times x plus something. Or it could be minus, like p could be a negative. So you'll always have an x at the beginning of each. There are ones where it might be something like 2x. But we're not going to look at that this semester. That's next semester in Math 10C. You're going to extend to those. Okay? And some other types of factoring. So you're going to do a whole bunch more factoring for today, for this course, just the very beginning. So that's what it's going to look like. So how do we figure out the value of P and Q? So as I just said, we want to look at here the constant term. Okay? So 4 we found by 1 times 4. 15 we found by negative 5 times negative 3. Negative 60 was 12 times negative 5. And then they added to those coefficients. Okay? So the values of P and Q must multiply. We're going to write it out in words. I've summarized it, but I want you to write it out yourself. Okay? So here, we know that P times Q has to equal the C value in our original, that constant term. And P plus Q has to equal the B value. Okay? So we need two numbers. So this is basically what we just set up here. We need to find two numbers that multiply to C and add to B. So two criteria to choose those numbers. Okay, phones need to be away. This is not easy stuff. You need to focus. You'll have lots of time to be on your phone next week. Okay, so here's a new question. X squared plus 11x plus 28. Factor it. First thing, you always want to look for a greatest common factor. Is there a number or a variable that goes into every term? Okay, well, coefficient is 1, so there's nothing that goes in. You don't include 1. Okay, and there's not an x in all of them. So, is there a greatest common factor? No. Second step is to recognize the type of polynomial. Is it an x squared term, an x term, and a constant? Yeah. Okay. So, if it is, so this is all in words. You're not going to write out words every time you do a question, but these are the steps that you have to think about. So, because it's of that form, we need to find two numbers that multiply to 28, the constant term, the one that has no variables, and add to 11, the x term, the coefficient of the x term. Okay, so now you want to think about those factors. You can use your calculator. I always start with 1 and the number. So 1 and 28. Okay, well, does that add to 11? No. 2 and 14. Does that add to 11? No. 3 doesn't go in. 4 and 7. Does that add to 11? Yeah. Okay. So 4 and 7 are the two numbers. No other combination works because you could have, if you had them both negative, they would multiply to positive 28, but they would add to negative 11. So sign is important. Okay? But if these are all positives here, then you're going to just deal with positives. So is there any other combination? No. So now we show it with two brackets. You can set that up no matter what. X at the beginning of each. Okay, and then your two numbers. I just want to. Yes, sorry. So your two numbers are 4 and 7. So you need an x plus 4 and an x plus 7. Okay, that you're done. You can always check it. If you expand that back correctly, you should get the original trinomial expression. Okay, so that's what we're going to do here. So we're going to take x plus 4 times x plus 7. So first together, outside, inside, and last. And then you collect like terms. Make sure that's the original expression. We can do that all next week. Okay, so then turn to the next page. There's another one there. You're going to do the same process. Okay. Check. Is there a common factor? Okay. Yep, so let's take a look. So 3, absolutely. And if yes, factor the 3 out. So remember from yesterday, we show a 3 with a bracket, and we divide everything here by 3. So that's going to leave us with m squared minus 2m minus 8. That's your first step. So every term gets multiplied by 3. Okay? We don't have x's, we have m's. It's still a variable, right? So is it an x squared and then an x term and then a constant? Well, it's an m squared, an m term, and a constant. So that's good. This plus doesn't mean anything. It could be positive or negative. This just means that b is negative 2, right? So yes, it is of that form. Okay. So we only look in the brackets. That's what we're factoring now. So we want to find two numbers that multiply to the constant term and include the sign in front. Really important. And add to the coefficient of m, which is negative 2. Okay. You can never start with this. There's an infinite number of numbers that add to negative 2 if you're allowed negatives. You could have 100 and negative 102. Okay? You could have a billion combinations. But there's a limited number of factors of negative 8. So you might want to start with negative 1 and positive 8. Okay? Does that add to negative 2? No. So then negative 2 and positive 4. That adds to positive 2. So what could I change so that it would work? If these add to positive 2, but I want it to be negative 2, what could I change here, Michaela?
Change the 4 to negative.
Right. So change that to negative 4 and this to positive 2. Okay, they still multiply to negative 8, and if you add them together, they give you negative 2. So those are our two values. So 2 and negative 4. Okay, so completely factored form, we have to copy out the 3 that we common factored. And then we have, not x, we have m, sorry. Okay, and then we have plus 2 and minus 4. Okay, that's your factored form. Check by expanding. Remember, check by expanding. I leave the 3 out and I do the two binomials together first. So m times m is m squared. M times negative 4 is negative 4m. 2 times m is plus 2m. And then 2 times negative 4 is negative 8. Okay, collecting like terms inside the brackets. Okay, you get this expression, which is what we factored. Expand that out, and you get your original expression. If you take a look back at the top, it's exactly the same. Next one, greatest common factor, there isn't anything. Remember, we're talking about prime numbers. 2 and 7 are prime. So you know that no numbers go into them, and there's not an x in every term. So that's no. Is it an x squared, an x, and a constant? Yes. Okay. So we need to find two numbers that multiply to 7 and add to 2. Well, if you are dealing with a prime number, like 7, the only choice is 1 times 7 or negative 1 times negative 7. Neither of those add to 2. No. Okay, what problem do you run into? Can't find two numbers, it's two factors, let's say, of 7 that add to 2. Okay, so we say this is not factorable. So every trinomial of that form cannot be factored. A lot of them can, but not every single one. And so in 10C you'll do more factoring, okay? And then in Math 20, you'll talk about ways that you can figure out these ones that can't be factored. Okay, so I want you to work on the ones listed there. Okay, so you're looking for two numbers that multiply to 20, add to. Okay, so in the next one, you can even put brackets if you want, if you need to kind of show your work. You don't have to, there's no marks for work, really. But you're looking for two numbers that multiply to negative 18 and add to negative 7. So 1 and 18, where one of them is negative, right? Either the first one or the second one. But I just even stop at that because I can think about that in my head. They're not going to add to negative 7, right? So even if you didn't show both. Then 2, you could go negative 2 and positive 9. Okay, that would be 7. Or negative 7. Again, why bother showing both of them because it's not, oh, sorry. That is this one. This one's positive 7, and this one's negative 7. So this one is what you need. Okay? You could do 3 and 6, but that wouldn't add to negative 7. So we're done here. And so in our bracket, we're dealing with m's. So m goes first, and then one of them's a positive 2, and one of them's a negative 9. So subtract 9. Okay, so when we write this out, you're going to have p as your variable, and the two numbers are negative 1, so we'll put in p minus 1, and positive 9 is p plus 9. Hint on the next one, they're all even numbers. So factor out a 2 first before you do anything else. Okay, so you'll be left with x squared plus 2x minus 24. So in your final factored form, it's going to have the 2 out front, 2 brackets, x at the beginning of both, and then remember you're looking for two numbers that multiply to negative 24 and add to 2. Okay, so one has to be positive, one has to be negative if they multiply to negative 24. And if they add to 2, they're going to be pretty close to each other, right? They're going to be 2 off, 2 different from each other. So that helps you when you're looking for factors. So 1 and 24 is going to be off, too far apart. 2 and 12 is going to be too far apart. 3 and 8 is going to be too far apart. But how about 4 and 6? If one of these is negative, so if I did this one negative, I'd have, they'd add to negative 2. I want positive 2, so they've got to be negative 4 and positive 6. goes into all of them, but I see x's in all of them. Right now, none of these had x cubed. So we don't know how to factor that unless we can factor out an x to start. And because there's an x in all of them, we can. So common factor of x. So divide everything here by x, which reduces the exponent in every term. Okay. Then that's a trinomial that we can factor. We need two numbers that multiply to 30 and add to negative 13. So your final factored form. So you can almost fill in all of it, okay, except for those constant terms. So now think of factors of 30. So if that's positive, then they both have to be positive or both negative. Well, if the factors are both positives, there's no way you can add to get a negative. So these are both going to be negative numbers. Okay, so think of factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. So if you had got the signs wrong and said positive 2 and negative 15, that would add to negative 30, but that would not multiply to positive 30. They both have to be negative. So this doesn't work. But the next one does. Negative 3 and negative 10, multiply to 30, and add to negative 13. Okay, so minus 3 and then minus 10.